All right, thanks for being here. Woo! So we are helping you get ready for our Q1 final exam. Whoa! All multiple choice. So we got Molly, and we also have Cambrian and a name drop. Whoa! So they stopped by after school to get some help. Okay, here we go. Lost some weight there. Lost 4 pounds. Okay. So Mr. Williams, so maximization problem, perimeter. How do you find the perimeter? So you find the perimeter by adding up all the lengths and all the widths. So we have a length here. We have 1, 2, 3, 4 widths. Wow. So 2 lengths plus 4 widths is equal to the total feet of fencing we have. We want to solve for L. So we're going to go ahead and minus 4W to the other side. And then we're going to divide by 2, divide by 2, divide by 2. So L is equal to, so we got 1100 divided by 2, is that 5500? What the? There we go. So we got 550, Okay, so we have 550 minus 2W, because 4 divided by 2. Okay, so that's one formula. Another formula to help us is the area, since we're trying to maximize the area. And so area is just equal to, let's do a different color. So it's equal to the length times the width. So we can combine those two functions together. So we take 550 minus 2W, and wherever you see an L, you're going to plug it in its place. So that's going to go here in place of the L. So we get A is equal to 550 minus 2W times W. And so that's our maximization. That's our maximization formula, right, that we're going to use. So then we go ahead and set each of those equal to 0. So W equals 0, that's one of them. W equals 0, it's going to be a graph. It's going from 0 to some other number. So then we go ahead and also set the 550 minus 2W equal to 0. We're going to add 2W to the other side. And now we're just going to divide by 2. So that's not our max width, but that's definitely the furthest our width maximization function will let us go. And so now we're going to do 550 divided by 2, which is 225. Nope, 275, Newbold. Okay, so then we get 275. So let's see here. So we're going from 0 to 275. So at 0, our maximization, our max area is nothing. At 275, our maximization area is nothing. That's just that width is too big for it to exist. So we're going to go in between, right in the middle. So you want to divide that in half. So we're going to take our 275, and we're going to go ahead and divide that in half. And that's going to go right there, and that's going to reach our peak maximization. So we get 137.50. So 137.50. So that's going to be up here for our x value, which is that is our maximum width now, because it's tied in with our maximum area. So max width is 137.50. If we could just find the y value, then that would be our max area. And we can't find the y value, because technically this function we found, you can say that area, right, that's y. So that's going to be what we do now. We use this equation, our maximization equation, and we go ahead and plug in the 137.50 into the equation, right, into the equation. And so now we get our calculator, and we go 550 minus 2 times 137.5. Good. Remember to close that second parenthesis. It all needs to be together. So 550 minus 2 times 137.5. And then that also times the W, our max width, which is 137.5. And that is going to give us our max area. So 37,812 is our max area. You can see here. So determine the max area as well as length and width. Okay, so that's 37812. 37812.50 is our max area. And I think that's in feet, yeah. So that's the max area, feet squared. And so we use that with the width now to get the length. Got to do some division there because we have a formula, remember? Area equals, so 37812.50 equals the length times the width. And so the width we already found, remember our width is 137.50. So we're going to just divide that to the other side. And that will give us our missing length. Solve for the length. Cool. So then we go to our calculator and we divide that by 137.50. Okay, 275 is the width, is the length, I mean. Okay, so that's our max area, good. And then our width was the 137.50. And the length is our 275 that we found by taking the area divided by the width. Way-o, way-o. Let me pause it. All right, and we're back there. So our next one has to do with combining functions and compositions. Do you remember how to do that? Could you do that on the final exam? Try to remind yourself. Remember, pause me. Pause me. Pause me. Try each one on your own. Then push play, see how you do in between each problem. Only way you're going to ace that final exam is if you pause me and try it on your own first, okay? Don't just watch. Don't just copy, you're going to fail. So make sure that you pause me and try it on your own. So the first one says to, we can make it easy, just plug it in and add them together. So we have 3x plus 1, so 3 times 3 plus 1, where we have x. And so we're just plugging it in there for x. This is technically what this is f of x equals 3. When they say f3, it's not, you sunk my battleship. So f3 is f of x equals 3. So x equals 3 is the input. You plug it in, you get the output. So when we plug that in, we get, let's change the color. So we get, plug in a 3 into the equation. So 3 times 3 is 9, and 9 plus 1 is 10, plus g of 5. So we plug a 5 in. So 5 squared plus 2 is, 5 times 5 is 25. So we get 10 plus 27 is 37. Way-o. Cool. So pause me, try the next one. So the next one is actually multiplication. Do you know how to multiply two equations together? So f and g, multiply it together. Pause me and try it on your own. So 3x plus 1 times x squared plus 2 is what we're doing next. So 3x times x squared is 3x cubed. Remember, x to the first power times x squared is x to the third. Okay, then 3x times 2 is 3x times 2 is 6x. 3x times 2. 1 times x squared is a 1x squared. And then 1 times 2 is 2. So usually we'd combine all the squareds and cubes and single variables and constant numbers, but it's already done. Way-o, because there wasn't anything to combine there. So now, do you remember how to do composition? Pause me, try it on your own, see if you remember. See if you remember. So we take f and we plug it into g. So we're going to take 3x plus 1, take f, and we're going to plug it right in there to g in place of the x. So now we get 3x plus 1 all squared. 3x plus 1 all squared. What else was there? Oh, plus 2. So the squared, square it, and then plus 2. So then we get 3x plus 1 times 3x plus 1. make sure that you actually times them together, because if you think that the answer is 9x squared plus 1, you'd be wrong because you forgot the middle terms. Forgot the middle terms. 3x times 3x is 9x squared, it is. But 3x times 1 is a 3x. And 1 times 3x is 3x. And 1 times 1 is 1. So we get 9x squared plus 6x plus 1. And you'd like that to be your right answer, but that's just what we found there. You still have to add the 2. So add the 2 there. And so you actually get plus 3. So our final answer is 9x squared plus 6x plus 3. Because you had to add the 2 at the very end. Okay, good. So this is going to be the same idea for number 7. So FOG actually means f of g of x. And so FOG, this is actually a composition. That means composition. So now you're going to take G and plug it into F, which is the easier one. That's the easier one. So we take F of X, which is 3x plus 1. And in place of the X, you're going to plug G in there. You're going to plug G in there. You're going to plug G into F. So that means the X goes away. And in its place is the G of X, which is x squared plus 2. So you're going to take that function, boop, 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 boop. You're going to plug it right in there. You're going to plug it right in there in place of the x. That's how you do compositions. So 3 times, yeah, I see this one easily being either of those being on the test. So that's going to be 3 times x squared is 3x squared. 3 times 2 is 6 plus 1 is 7. Combine the 6 and the 1. And that's our answer. Way-o. Okay, what about h of f of 1? Scary. So you want to deal with the f of 1 first. X equals 1. So we plug it in there. F of x is 3x plus 1. So just going to plug that 1 in there. So we get 3 times 1 plus 1. So that's just 3 plus 1 is 4. Way-o. But that's just the first part, right? That's input of 1, output of 4. And then 4 becomes the input for the next one, and then you get your final output. Input, output, becomes the input, final output. So now we do h, which is 2x squared plus 4. And now we're going to go ahead and take that 4, that becomes an input, output becomes the input. So then we get 2 times 4 all squared plus 4. That's a lot going on there. That's a lot going on there. So then 4 squared is 16. 16 times 2 is 32. Plus 4 is 36. And you still have to do the square root, which is 6. Way-o. So that's the answer there. The answer is 6. Can you take an equation and minus it with another equation? Right? Distribute that negative through. Distribute the negative through. Pause me. Try 5 on your own. Went out of order there, but that was fun. Pause me. Try it on your own. So g of x is x squared plus 2 minus f of x, which is 3x plus 1. And so I think the biggest mistake, that's an easy problem I've seen on the test. So the biggest mistake is to change the signs on both terms, okay? That's an invisible negative 1, and you're distributing it through. So we get x squared plus 2 minus 1 times 3x is a minus 3x. And minus 1 times 1 is a minus 1. Combine like terms. So we get x squared minus 3x, nothing to combine there. And then we do have a positive 2 with a negative 1, and 2 minus 1 is just 1. Whoa! Subtraction. Distribute the negative. Combine like terms. Nice. Determine whether expression are equivalent without a calculator. Show all work. You remember doing a problem like this? So you distribute, before you distribute the negative, you do have to distribute this through seashell. So that's 3x squared times x squared is 3x to the 4th power. 3x squared times just a 4 is 12x squared. Minus 1 times x squared is a minus 1x squared. And minus 1 times 4 is a negative 4. We're doing PEMDAS. We're doing parentheses first and then exponentials and multiplication. Okay, let's see here. So combine like terms. 12 minus 1 is 11. So we get 11x squared there. Good. So now we're going to bring down that negative, and we're going to go ahead and distribute it through and change the signs. So negative 3x to the 4th power minus 11x squared plus 4. Pause me. And then we can bring down the 7x to the 4th power plus 1. And all I can see is that, oh, we can combine the four powers. So 7x to the 4th minus 3x to the 4th is 7 minus 3 is 4. 7 minus 3 is 4. The x to the 4th comes along for the ride. We also have a plus 1 and a plus 4. So that's going to be minus 11x squared. And then we have the 1 and the 4, which is 5. Woo, we did it. So there's one side. There's one side. Distribute that through. So 2x squared times x squared is 2x to the 4th power. Minus 2 times 3 is 6x squared. Plus 2x to the 4th minus 5x squared plus 5. Whale. Combine like terms. Combine like terms. So we have a 2x to the 4th power right here and here. So that's 4x to the 4th power. Ooh, that's the same. That's good. Then we have a negative 6x squared with a negative 5x squared. So negative 6. Took six apples off my tree. Then you took 5 more. How many do you owe me? So that's 11 apples. So minus 11x squared. Good. And then plus 5. Whoa. Whoa, look at that. They're the same. They are equivalent. They are equivalent. Could you do that one on the final exam? If I gave you one like that, could you do one like that? It takes a bit of work. Maybe make it a smaller nibble on the test. Do you remember how to take points on a graph? Do you remember how to take points on a graph and do stuff with them? Do some transformations. So this is going to be the x value specifically. Yeah, put it on your note card. So instead of timesing, right? Instead of timesing, actually we're going to do the opposite whenever it's the x values. And so you're going to go ahead and divide by 3 to the x values. It's the opposite, so it says times, but you actually have to divide. Then the minus 5 is actually what it is, and that's to the y values. So here we go. They gave us some points. Negative 9, 2. And you're going to divide by 3, and you're also going to minus 5. So then negative 9 divided by 3 is negative 3, and 2 minus 5 is negative 3 is our answer. That's an easy one. I can see that's on the final exam. So what if we have a half in the front? What does that mean? So that means to multiply. So multiply the y values by a half. So times it by a half. Then add 1 to just the y values. Write that on your note card. Write that on your note card. That's an easy one. It's going to be on the final exam. And then this is opposite, so we're going to add 5 to the x values. Write that on your note card. Pause me. Try this on your own. Stop watching. Pause me. So we have negative 9 and 2 is what they originally gave us. And so let's do the x. That's pretty easy. Just add 5. So we get negative 9 apples off my tree. You gave me 5 back. You still owe me 4 apples. And then what are we going to do with that 2? Ugh. So we're going to times it by a half. So what's half of 2? Just a 1. And then we got to go ahead and add 1. So then we're going to go ahead and add 1 next. And that's back to the 2. That's silly old bear. Yeah, Paddington Bear. No, Winnie the Pooh. Silly old bear. Okay, so that's how we do those ones. That's how we do those ones. So see you next video. How we convert quadratic functions to vertex by completing the square. That'll be on the test. Thanks for watching. Next video. Here we go. Thanks for watching.